This is Professor Derek Seitz. Counting. Counting is essential for calculating probabilities. This spreadsheet contains 4 different counting scenarios that are common. The first one calculates the number of ways that 2 events can occur in sequence. It requires as input M, the number of ways that one event can occur, and N, the number of ways that the other event can occur, and then it's their product, M times N, that gives you the number of ways they can occur in sequence. It's a simple formula, but having it like this organizes it, makes it easy to remember what to do. The next section takes a number n and calculates n factorial. The n with an exclamation point, that's read n factorial. And what that is, it's the number times 1 less and keep going down. So in this case, it's 5 times 4 times 3 times 2. And we throw in the times 1, even though that doesn't do anything. And what is the result? It's the number of different ways you can order 5 things, where order is distinguishing. If there were 5 numbers, 1, 2, 3, 4, 5, then 1, 2, 3, 4, 5 is a different order than 5, 4, 3, 2, 1. And it turns out that there's 120 permutations of 5 things in factorial. The formula uses the fact function in Excel. It stands for factorial. Also, n factorial occurs in some of these other formulas that we don't need to calculate because Excel provides functions for them, but you may need to calculate a factorial for some reason besides just finding a permutation. The next section is now where we take a subset of the items and how many ways can we take, in this case, 3 items out of 5 where the order makes a difference. For example, a 1, 2, and a 3 is different than a 3, 2, and a 1, and a 1, 4, and 5, and a 5, 4, and 1. The number of permutations, different orderings of 3 things, any 3 items out of those 5, 60 different ways. The function for this is permute, stands for permutation, and it takes the total number of items and the number that you're taking in one examination, R, 3 in this case. Remember, permutations involve order being important. The next group is combinations. Taking how many ways can you take 3 things out of 5 where the order is not important? What that means is a 1, 2, 3 is the same as a 3, 2, 1. They are not distinguished as different cases. These are combinations, and it turns out that there's 10 different ways, and the function is combin from combination, and it takes, again, the total number of items and the number that you're taking out at any given time.